line. In the diagram, O is the center of the circle, ST is a tangent to the circle, and T, M and P are points on the circle such that TM is equals to MP. So it looks like T2 is equals to P1, angles opposite equal sides. And thereafter it says that OT, OP, and TP are drawn, and let O1 is equals to X. So our job here, okay, let's first read the question. Prove the reasons that STM is equals to a quarter X. So STM is basically T1. So what do we require to prove RTP is that T1 is equals to a quarter X. So if we need to bring, so the only X we have is this one here, and we basically need to start moving it towards the outside of the circle. So firstly, we need to understand that, okay, this is a radius, this is a radius, so we might use that, we might not. TO is equals to OP, which is radii. Just gonna write that down first. And so the other triangle, the angles equals opposite sides. And what we can get is we can get O2, because that's angles around a point. And once we get O2, we'll be able to get M, because that's angles at center is equal to twice the angle at the circumference. So firstly, O2 is equal to 360 minus X. And our reason is angles around a point, or angles in a revolution. And therefore, we can say, therefore, M is equals to half of that, which is 180, minus half X, which is angles at center, is equals to 2 times angle at the circumference. And what we can also note from that is, once we have that, we can figure out what T2 is. So let's go fully in these values. So 360 minus X, that's that. M is 180 minus half X. And if we add T2, P1, and 180 minus half X, we should get 180, because that's the sum of angles in a triangle. So therefore, we can say that T2 plus P1 is equals to half X. And how do we get that? That's the sum of angles in the triangle. Because if we take these two, if we take 180 minus half X plus half X, we get 180. So these two added together should give you half X, to cancel out that half X into of M, to get 180 degrees for the all three sides of that triangle. So therefore, if that is half X, therefore T2 is equals to P1, which is equals to quarter X. And the reason is angles opposite equal sides. And then lastly, what we can do is now, so if this is a quarter X, so let's just make it X over 4 because of space. We then have this tangent. So if we have this tangent here, and that's an angle of the tangent, if we use this chord, that gives us 2P1 here. And that actually proves, using the Tanko theorem, that T1 is equals to P1, which is equals to a quarter X, which is what we wanted. And our reason is tan chord theorem. So this would essentially be the shortest way to get STM to be a quarter X. And let's just change this here. Let's just call it STM. That's what they asked us to. They didn't call it T1. So STM is equals to P1 is equals to a quarter X, Tanko theorem. So there are other ways. There is one or two other ways you could have expanded the sum of angles of triangle if you wanted to, but you would still come to the same answer.